This is a solution of problem number 25 from homework 3.1. We are given a quadratic function in general form, h of x equals 4x squared minus 4x plus 21, and we're asked to graph that. And we also have to find some key characteristics, the vertex, the x-intercepts, and the y-intercept. And then we're asked to sketch the graph. So the first way I'm going to find the vertex is to complete the square. This is one method. So completing the square, I'm going to write h of x is equal to, I'm going to move the 21 off to the side a bit, and then I'm going to factor out the coefficient of x squared. So I'm going to have 4 times x squared minus x, and then I'm going to put plus. And the idea here is I want to add a constant, and the constant that I'm going to add is going to be the one that's going to make the expression in the parentheses a perfect square trinomial. That is going to be b over 2 squared for the stuff in parentheses, which here is negative 1 over 2 squared, which is 1/4. So I'm going to add 1/4 inside the parentheses. But what I need to be really careful about is I really didn't just add 1/4 to the right side. I added 4 times 1/4, which equals 1. So I added 1 to the right-hand side. Now I need to subtract 1 to keep it an equivalent expression. Okay, now we can go ahead and put this in vertex form. So we're going to have h of x equals 4. X squared minus x plus 1/4 is x minus 1/2 squared, because it's a perfect square trinomial. And plus 21 minus 1 is going to be plus 20. From this is the quadratic function in vertex form. The vertex, remember this is our h and this is our k, so negative 1/2. So our h is going to be 1/2 and our k is 20. So that's our vertex, 1/2, 20. I'm going to go ahead and plot 1/2, 20, so we have that for later. The second way that we can find the vertex is to remember, so I'm going to make a second method here. So this would be method 2, is to use the idea that the x value of the vertex is always at x equals negative b over 2a. And that comes from this original expression here. So negative b over 2a is going to be the opposite of negative 4 over 2 times 4, which is 4 over 8, which is 1/2. So the x value of the vertex is 1/2. And then to find the vertex, I need to find the y value. I simply substitute 1/2 into the h of x function. So that's going to be 4 times 1/2 squared minus 4 times 1/2 plus 21, which is 4 times 1/4 minus 4 times 1/2, which is 2 plus 21. So this is 1 minus 2 plus 21, which is 20. So the vertex is the same thing we got last time. It's going to be the point 1/2, 20. And you can solve these either way. Now let's find the x-intercepts. To find the x-intercepts, you're going to let y equal 0. It's going to be easier to find the x-intercepts if you use the expression in vertex form. So vertex form is this equation here. So let's let 0, h of x, is going to be equal to 4 times x minus 1/2 squared plus 20. Bring the 20 to the other side. Negative 20 equals 4 times the quantity x minus 1/2 squared. Dividing both sides by 4 will give us negative 5 equals x minus 1/2 squared. And once we take the square root of both sides, we're going to see that x minus 1/2 is equal to plus or minus the square root of negative 5, and that is not real. So there are no x-intercepts. Okay, and then the y-intercept, to find the y-intercept, we're always going to let x be 0. So we're going to find h of 0, which is going to be easiest to use the general form. So it's 4 times 0 squared minus 4 times 0 plus 21, which is 21. So the y-intercept is a point 0, 21. Let's put that on our graph. And the axis of symmetry is the line, vertical line through the vertex. So that's x equals 1/2. I can get another point by symmetry. I can reflect the y-intercept 0, 21 over the axis of symmetry. So it's a half a unit to the left. So I need to go a half a unit to the right of the axis of symmetry, giving me the point 1, 21. Finally, we need to sketch the parabola. So we draw a nice smooth curve through these 3 points. And there we have it.